Hello everyone. I'm Varshat Nikhila, Assistant Professor in the Department of Information Technology at Vailtech Multitech, Dr. Rangarajan, Dr. Sagunala Engineering College. In this video, we are going to take a deep dive into the world of computer generated imagery. We will understand how it used to build immersive environments in games, films, simulations, and much more, from color grading and lighting to physics simulations and modeling. So, CGI. CGI is basically stands for computer generated imagery. It is a backbone of digital visual today. Whether it's a dinosaur in Jurassic Park, the massive battles in Avengers, or even the background of a car commercial, CGI is everywhere. But isn't just limited to pretty images. It builds entire digital worlds where physics, light, and movement feel real. These aren't static backdrops. They are interactive, dynamic environments that respond to the user or character's movement, especially important in games and simulations. Mastering CGI means understanding how light, surface, color, and physics work together to form believable visuals. So, CGI is the CGI means a virtual environment. How the virtual environment are crafted, the science behind the realistic of color and lighting, and the advanced techniques that brings visual effects to life, and the applications of CGI. CG has endless application in entertainment. If you take entertainment, it used for everything from fully animated films to subtle background effect in live action scenes. In advertising, it helps create polished and product visuals and futuristic scenes. In architecture, CGI allows architects and clients to walk through a building before it even exits. Then complete with guideline lightning and textures. And in education, CGI is used for medical stimulations, virtual science labs, and historical recreations like that. The goal to inform, entertain, and immerse the viewer visuals that we were once impossible. And the evolution of CGI. If we take a journey of CGI has been nothing short of incredible. Back in 1980s, CG consists of basic wireframes and primitive shapes. But today, it includes lifelike human fluid stimulations and photorealistic textures. With the introduction of powerful rendering engines and real-time graphics, we can now stimulate things like hair strands blowing in the wind or accurate shadows moving based on light angles. So, what once took hours to render now happens in real time thanks to the GPU and ray tracing technology. CGI continues to evolve and it's heading toward hyperrealism and AI assisted automation. Now, understanding of visual worlds. Uh, what are exactly visual worlds? Means they are digitally constructed environments that are stimulated, real or fictional places. Think of video games like Skyrim, virtual meetings in Meta Horizon, or VR stimulation for military training. These worlds are made up of terrain modeling, design the landscapes like mountains, rivers, and valleys. Object placement like where buildings, trees, and items are positioned. In environmental effects means weather, time of day, fog, wind, all contributing to immersion. So each of these elements is carefully designed to maximize realism and interaction guidelines. So the virtual in user interaction in virtual world, interaction is key. Users are usually represent to avatars, their digital self. These avatars walk, talk, interact with others, or even perform complex tasks. Interactivity includes picking up objects, opening doors, driving vehicles, communicating with other users. This interactivity add another layer of realism and is especially important in training, simulations, and multiplayer games. So, and also the photorealism in CGI. The photorealism aims to make CGI look so real that you can't distinguish it from real photograph. To achieve this, artists and developers use ray tracing. Tracing means it's stimulating how light behaves in the real world. Global illumination, capturing how light bounces off surfaces. Texture mapping, adding real world image textures to the object. However, achieving the photorealism is difficult because of the complexity of light behavior and material properties, like how shiny, rough, or translucent our surface is. Then, physical realism. If we took a look on physical realism, while physical realism deals with appearance, physical behavior, it focuses on how objects move, collide, deform, or flow. There are two major branches: rigid body dynamics and soft body and fluid simulation. If we took a look at rigid body dynamics, stimulating hard, then non deformable objects like rocks, walls, or vehicles. In other hand, the soft body and fluid simulations, which cover things like cloth waving, jelly wobbling, and water flowing. Physics engines stimulate gravity, collision, mass, friction, and force, making the virtual world feel physically grounded. So, the photorealism is a deals with appearance, physical realism deals with behavior. So, have a clear note. Physical realism it focuses on how objects move, collide, deform, or flow. And to understanding the function realism. Now, let's talk about function realism, a lesser known but incredibly important aspect. It's not just about looking or moving realistically, it's about making things usable. For For example, in a VR surgery simulation, a scalpel must behave like a real one, not just look like it. So, designers focuses on interaction logic, initiative behavior, ergonomics, like that. The function realism is crucial in training simulations, interface design, and a serious gaming. So, function realism emphasizes the functionality and usability of virtual objects rather than their visual objects. Then, 3D modeling techniques. So, all CGI starts with a 3D model. So, there are a different technique like polygonal modeling, NURBS modeling, digital sculpting, like that. In polygonal modeling using geometric phases to build shapes. In other hand, NURBS, it's used for ideal for smooth curved surface like a car bodies like that. In digital sculpting, it is a great for organic shapes like phases or creatures, like that. Then it's a clean topology, correct polygon count, and UV mapping ensures the model works well in animation and rendering. Popular tools include we have used Blender, Maya, and ZBrush. These are the major software that used for 3D modeling. Mm. Then rendering techniques. Basically, rendering techniques transform the 3D world into a 2D image. It stimulates how light interacts with the surface, shadows, and reflections, and more. Rendering is the process of generating a 2D image from a 3D model by stimulating light transport. So, and There are two types of rendering dominate. First one is a predefined, pre-rendered and real time. Pre-rendered used in movies. It's time consuming but very high quality. In real time, it's used in games. Happens instantly as you move through a scene. So popular engines include Arnold, V-Ray, Octane Render, and Unreal for real-time output. So real-time render used only in games because it happens instantly as you move through a scene like that. And the pre-render used in movies, it is very high quality, but it took a lot of time to build effects. Then color spaces of in CGI. Color space define how colors are represented and interpreted in a digital environment. Color spaces and depth are crucial for digital imaging. Understanding these concepts helps enhance image quality and achieve desired artistic outcome in CGI projects. So, for example, mm, RGB. RGB stand for sRGB stand for web. Adobe RGB is used in print. ACES is common in cinema workflows. Color depth define how many shades of each color can be displayed. The higher the bit depth, the more accurate the color. This becomes crucial in scenes with high contrast or subtle gradients. So the color grading techniques enhance the storytelling by adjusting brightness, contrast, and saturations like that only. And the color effects in CGI. Color effects in CGI. Color isn't just a technical; it's also a emotional because with color grading, artist can shift the viewer's perception, making a scene feel warm, cold, nostalgic, or dangerous. So here, here tools are like DaVinci Resolve, Adobe After Effects, and Nuke allow artists to adjust brightness and contrast, isolate color tones, and apply film looks. In advertising and cinema, color is used to control mood and messages. And understanding HDRI lightning. HDRI is a high dynamic range imaging. HDRI stands for high dynamic range imaging. It is a technique used for capturing a broader range of light intensities than traditional imaging. It means it captures lightning with far greater detail than standard photos. And the HRDI image is made by combining photos taken at different exposure level, capturing both shadows and highlights perfectly. This technique is used in CGI to light scenes naturally, and realistic reflections match the digital world with the real one. Architectural renders and VFX shots often rely on HDRI for lifelike integration. And lightning technique in CGI. Lightning is the soul of CGI. It affects realism, mood, and storytelling. So, lightning is the most important one in CGI. There are various types like point lights, area lights, mesh lights, and image based lighting. In point lights, it's like a light bulb. Area light means stimulate windows or fluorescent panels like that only. Mesh lights, custom shaped lines. And image based lighting use HDRI maps to provide realistic environment light. So, proper lighting makes the difference between a flat render and a cinematic masterpiece. And to the introduction to PBR lighting. PBR is a physically based rendering. It is a game changing lighting technique. because it stimulates light interaction based on real world material properties. The key BPR parameters are albedo, metalness, roughness, normal maps, like that. Albedo is base color of the object. Metalness is how metallic it is, and roughness is how shiny or matte the surface appears. Normal maps add fine details like bumps and wrinkles. BPR ensures consistency across lighting, and setup is widely used in games and films. And photometric lighting. To understand the photometric lighting, it refers light measurement that account for human perception. Means the photometric lighting use the real world lighting data like brightness levels, beam, and angle temperatures. Lighting manufacturers often provide IES profiles which can be imported to 3D scenes. This helps architects and designers match CGI lighting with actual products used in construction or sets. It's a vital for architectural visualization, automotive renders, and any scene requiring precise lighting conditions. Then PRDF shading. PRDF means bidirectional reflectance distribution function. It describe how light reflects off a surface. Different BRDF module include Lambertian for matte surface, Pong for older specular highlights, Cook Torrance for realistic glossy reflections. So these shading models stimulate different materials types, whether it's velvet, chrome, or human skin. They are essential for rendering materials accurately and behaviorally. And the last one for is conclusion. And as we have seen, CGI is more than just visual effects. It is a fusion of art, physics, programming, and design, all working together to create digital magic. With ongoing advances in AI, real time rendering, and interactive simulations, CGI is the only going to become more powerful and accessible. Whether you're an aspiring artist, developer, or just a fan of great visuals, understanding the core principles of CGI opens the world of possibility. Thanks for watching. Thank you.